Welcome to our data flow diagram presentation by Larry Scott and David Durant.
The first question that we need to address is, what is a data flow diagram? Primarily, it is a graphical representation of your program. It shows in a visual way how your data flows through the program, from input to output, and how it is used and transitioned throughout that time. We do this through the use of four main symbols. They are to represent the external entities, which we use a rectangle. For the processes, we use a circle. For data storage or databases, that type of thing, would be an open-ended rectangle. And the data flow is represented with an arrow.
Here is a summary of the data flow diagram examples we will go over. The first three are examples pulled from the website Geeks for Geeks. They are demonstrations of how much information is included in the diagrams based on how much is needed. They use purchasing tickets for a railway company as a way to demonstrate the flow of data. The next two are diagrams I made for another class and are based on code provided by the class. Lastly, we will go over the diagram I started for our periodic table memorization app. Here is an example of level 0 data flow diagram. It is a very high level diagram as very little information is included. Despite not including many of the internal processes, it is easy to understand and gives a good overview of what the program should accomplish. This next example gives more insight into how the internal processes pass the data back and forth. Despite providing more information than the level 0 diagram, it still is a basic view. This level might be good for programmers who are coming into the project and need a visual representation of the flow of information. This is a more in-depth diagram on how the information for purchasing tickets is passed around and processed. This level of data flow diagram is harder to understand but provides the needed insights to help a programmer understand where all the data is moving to. As you add more information to the diagram, it gets more scattered and difficult to read. It is important to organize it as best possible. This level of diagram is not good for non-programmers as it will just leave them confused. Some sites hint that there are more levels to the data flow diagrams, and that you can include so much information that the next level would be pseudocode. Rarely is that much information needed in a diagram. This diagram is based off a simple password checking program. The purpose of the project was to follow the user inputs and check for vulnerabilities. This view of the code can be misleading as the data follows a similar path as the flow of the program. It is important to emphasize that data flow diagrams are not flowcharts. They are not based on the flow of the program, but where the data flows. This concept will be more apparent in the following example. Like the previous slide, this is based off code provided by the class and used to see where the data goes. Unlike the previous example, the data doesn't flow similar to the flow of the program. It is a much more complex program, but it also helped to improve my understanding of the 1700 plus lines of code. Here is the start of the data flow diagram for the periodic table memorization app. It is a pretty high level view. I would probably put it in a level 1. There is still information missing, but it gives a good idea of where the data needs to go. It was harder to make this diagram than the last two, as I didn't have code to base it off. As we work out more of the details for the STD, we can continue to add more details to the diagram, giving us all a good overview of the flow of data.
There are several advantages to a data flow diagram. First, it describes the boundaries of the system, which shows you what your system can and can't do. It communicates the system knowledge that you presently have in an effective and easy to understand way. Because it's graphical, it's much easier to understand than pseudocode or UML diagrams, especially if don't have the technical background for programming. It can show a stakeholder, for example, how the program is going to work and how the data will flow in a more easy to understand format. It also gives a detailed representation of the system components, helps you to see what components you needed and how, in what way they interacted to some degree. It can also be included in system documentation, which is becoming more and increasingly important in this day and age. Rather than having programs that are undocumented, we're encouraged to document our programs so that they can be more easily maintained. And they support the logic behind the data flow. They help to understand why the data is flowing the way that it does. There are also a few disadvantages to data flow diagrams. If you have a very large program, your diagram could be very complex, which would make it harder to understand, harder to track the data, and just more confusing overall. Also, for a data flow diagram, it can take a lot of time to create, especially in those more complex programs. And so it can be a very time-consuming process. And lastly, it doesn't really reference the physical considerations. It only tracks the data and how it flows through the program. So it doesn't give you a complete picture of all the aspects to your project.
The data flow diagram can be useful to get an idea of how different processes handle data. It will be useful in our production of the SDD. However, it is best not to load it too full of data, as the time commitment to gather all that information can decrease its usefulness to the project. It is also best to decide on one notation style to avoid confusion of symbol meanings. Thank you for watching our presentation.
Thank you for taking the time to view our presentation. If you're interested in learning more about data flow diagrams, you can take some time to review these sources that we used during our presentation. Thank you.